So, good morning, everybody. Welcome back to Algebra 2. We are still in polynomials. We're beginning our graphing series, section, unit, whatever you want to call it, okay? We're going to be dealing with actual pictures this time. And we're going to start this one in the simplest way possible. We're going to start with the plotting points, okay? And then we'll go from there, because I want you to start to pick up on those patterns. See if you can develop a system, I guess, the pattern recognition of the polynomials and what they end up looking like, and see if you can figure that out yourself. And we'll summarize it together and put it together in some shortcuts next week so that you can just whip up a quick sketch. That's my ultimate goal, is for you to be able to not have to rely on, say, the calculator. You can get a quick visual picture both in your head, and you could whip it up on paper and be like, oh, okay, it's got that power, it's that sign, so it's just going to look like about that. Okay, that's what we're going for. But before that, let's go back to yesterday's work and run through the answers to those questions, the rational zeros for these polynomial functions. So go ahead and open that up and compare your answers to mine here on screen. Remember, the multiplicity, abbreviated mult, means that that same zero appears more than once. So you could divide out the same number again. It's kind of a tricky notion, especially when you're searching through. Like, I know there's supposed to be 3 of them, but where'd the other one go? Nothing else works. Did you try one of these again? This is where the graphing is going to come in handy. Because with a combination of the picture of the graph and these techniques for finding the actual solutions and the zeros, you can quickly see, oh yeah, okay, it's supposed to have 5 roots, but one of them is a duplicate, right? So you can kind of see that coming there. And then here is the last one. The critical question: if you checked all these things, they don't work, you divide by one that does, do you have to check them all again? The answer is, of course, no, not at all. If it doesn't factor in the bigger version, it's not going to be a factor of the factor, the smaller number. Nope, that's the beauty of factors. That's one of the reasons mathematicians put such a big emphasis on finding prime factor, the prime factorization of numbers, because it is immutable. It's inevitable, right? Anyways, any questions from this sheet? No? All right, then here is our work for today. Yes, that's the one. All right, graphing polynomial functions. So the tried and true method, the way that'll always work to get you a picture. It's not always the best picture, depends on how much effort you're willing to put into it. Ultimately, we're looking to draw the graph, but along the way, we can figure out where all of the real zeros will land. So this can also be another technique. If you create your rational root list, okay, I'm going to have all of these numbers, and you can quickly see, okay, one of them has to be a negative, and one of them has to be positive here. All right, watch for where your function transitions from positive to negative or negative to positive, and that will give you your range for the zero. And then you can look at your list and check, oh yeah, okay, I have 1.5 on my list. that must be one of the zeros because it fits in that slot right there on the table. Okay? So all of these things can be used in conjunction. Ultimately, at the end of this unit, as it were, you're going to have a whole toolbox. Okay? Lots of different screwdrivers and saws and hammers and stuff to get the job done. And some directions might direct you towards using one type or another just because it's a test. I want to make sure you're capable of using all of them. But ultimately, it's going to be up to you what you like best for determining these things. So today we're going to go nice and simple. We'll do it by hand. Tomorrow we'll incorporate the calculator. Well, you know what? Do you want to incorporate the calculator now? We've got calculators, right? We should just use them. What do you think? Should we just use it, or should you do it all by hand? You don't know? All right. We'll tell you what. We'll compromise. You can use the graphing calculator. I'll walk you through it, but only to create the table. Okay? Only creating a table. We're not going to copy the graph down. That would be a little bit cheating. Okay? So we'll just save ourselves the calculation. How about that? No need to plug these in by hand, compute. Okay, -2 to the 4th power times 2 minus -2 cubed minus 5. Whew. -1 to the 4th power. Right? That's going to get pretty repetitive. Agreed? That's what a calculator is for. That's why we have the technology. Take away the drudgery of the repeated things. Here's what we're going to do. We're going to use the TI-84. You have the app on your computer, right? To generate your table of values. And then from that table of values, I want you to plot points on the graph. Okay, by hand. So look at your table and then plot dot, 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 put a few dots, connect them with a beautiful line, and away you go. Now, I would use this example as your bare minimum. You need at least 5. However, I would say as a general rule, definitely at least 5. If you're asking yourself, how many points? Greater than or equal to 5. And I would also say greater than or equal to the highest exponent plus 2. So 5 is like our bare minimum. And that works great for a cubic. I would say go at least 2 higher than the highest power here. So this is a 4th power. I would have gone with 6. Okay, my recommendation. And we've got the calculator to help us out. So it's not like adding additional points is that much more work. Okay, I think we can handle that. So just for comparison's sake, exercise number 1 has a cubic, so get at least 5 points from your table. Number 2 is a 4th power, so get at least 6 points on your table. Reasonable? And that way you'll be sure to get, or hopefully sure enough, to get all of the bends there included. Okay? Now, how do you narrow down what range of values to use? Obviously, you want positive and negative. Okay? Always test 0. And that should be rule number 1, plotting points. Always include 0 on your list. Because if, at the very least, it's super easy to do, at the very worst, it's going to be a super complicated special point worth looking at. Right? Either way, you want to include that. Positives, negatives, just go by integers. 1, 2, 3, 1, 2, 3 is fine most of the time until you see that it's not. If you start plotting points, let's say, pretend, for example, this is what you find. You start doing question number 1, you're like, okay, I've got a cubic function here. I plot my first point, and it goes there. And then I get my second point, and it's there. And then it's my third point, and it's there. And it's like, gee, I kind of got straight line going here. That doesn't seem right. Okay? Use your intuition. Be like, this is a cubic power here. Cubics don't look like that. cubic parent function, right? Plain old x cubed looks like that. It's got some bend to it, right? You should expect that. Like, okay, I need to go a little bit further. Clearly, this is too far zoomed in. So if I zoom in right here, it looks like, that's about, a straight line bit right there. Maybe that's all we have. And actually, the values need to be a lot bigger. So maybe jump by 5s. Throw that off of the end. That would be my recommendation. If anything is fishy, you start with this basic set and something comes up fishy. Jump out to like 10 or negative 10 and see where that puts you, if that's continuing the trend or if that suddenly changes something. Because if this suddenly drops down to, negative 36, right, between 2 and 10 and 19 goes to negative 36, like, whoa, I missed something there. Let's go back and narrow in a little bit further so we can make sure we include all of those zeros and those transition points, okay? There's not a lot of hard and fast rules. You can, though, make special use of the graphing calculator. Take advantage of its automatically populated table, and you can just scroll through there and see, okay, where does it change over? How far do I need to go with this? And that can help you too. All right, any questions, overall big picture, before we go to the calculator? No? Okay, then let me switch to the right. Waha, there it is. Set that guy aside. Okay, you should be seeing now my calculator on screen. We're going to deal with a function. So the first thing we got to do is y equals button. Type in our function. Why don't we just start with number 1 as our example? Okay, so x squared. Remember, never use the alpha x. You're always going to use the variable button right here next to alpha. X cubed. You have options. When in doubt, caret to a number. That will work. Okay? Although, if you want to get fancy with it, I happen to know shortcut math 3 automatically puts a cubed there. And that's the only thing you need in the exponent. Notice our cursor now is automatically down here instead of still up in typing more exponent. The 84 plus anticipates you being fancy, and it likes to try to make the fancy easier, which sometimes makes the simpler require more button presses. So I would just go math 3 for the cube button. Minus 2x squared minus 2x squared is a button right there, plus 1. Okay? Should look like this. Make sure this is darkened in, so it is plotting this one. You can make it whatever color you want, ideally a solid line here. And if there's anything else in the otherwise, go ahead and clear those out. And none of the plots should be highlighted. Just double check that. And now we don't need to deal with all the zoom in and out and window settings. We're just looking at the table. Second table. There it is. And I'm not sure if 0 is always the default, but you can use your mouse button, scroll down, highlight other values, scroll up, and it just keeps going into the negatives. We can see here, oh my gosh, massive table. We get 10 entries at a time. How easy is that, right? So write that down. Boom. We're going to grab, let's see, it's a cubic, so let's grab at least 5 centered on the 0. So 0, 1, 2, 0, 1, and 2. There you have it. And it looks a little lopsided there, right? 2 only goes up to positive 1. And negative 2 goes way down to negative 15. So this is where that 6th point could come in handy. Like, why don't we round it off and be like, I'd go up to 10, you know? This is telling me I really want to include 3, 10 on my graph, if I can fit it. Okay? That's the other consideration there. This that has, if I go back to our view here, they're providing some pre-made axes for you. Again, you don't have to graph on this. You can graph it in your notebook, but do take advantage of the information they are secretly providing you with the pre-made axes. Okay? The book is doing you a lot of favors here. It's saying, hey, you're going to find some numbers fairly large, right? Because they go 2, 4, 6, 8 instead of 1, 2, 3, 4. Like, oh, so I should end up with like a number like 10, or what was the other one, negative 15, right? We're going to get close to that on here. So that's a hint. Also, the fact that it is perfectly centered in the middle is a hint that you more or less equal on both sides. Number 2, my x-axis is way up there. They are already anticipating moving that view window down to focus on the negatives. So I'll bet that a lot of these values are going to end up, or at least the interesting stuff, is going to happen in the negative zone here. Take advantage of that. Use that and study on your table. See, okay, does that fit? Am I going to get points that are going to make sense on the image they are providing? Okay. Maybe that'll adjust how many or which ones you want to focus on. Okay? And the other ones are, yeah, some variation therein. Nothing seems skewed left or right. So yeah, equal number, more or less, of positives and negatives there. So let me write down my table from here. I think you guys will be fine on your own, but let's do it together while we're here, just so we're all on the same page. So we'll grab -2, -1, 0, 1, 2, and I'm going to include 3. It looks like a good number. And that was -15, -2, 1, 0, 1, and 10. Do watch out when they do this thing to you where like 0, 1, 0, 1. Like, oh, shoot, make sure you keep those lined up properly and don't mix them up. All right. And plot points. -2, 2, 4, 6, 8, 10, 12, 14, and a half. Oh, that's going to be way down there. It's off the charts. And -1 is -2 there. Okay, 0 is at 1. Oh, what did I do here? No, I don't want to do the zoomed in thing. Thank you. And 1 is at 0. Oh, see, so it's coming back down. 2 goes back up to 1. It's a dot there. And then at 3, we go all the way to 10. So that helps solidify in. Yeah, it's taken off there. We can see that. And now we just go for a nice smooth curve down, up, down. Oh, I ruined it right at the end there. Hang on, let me use the partial eraser here. And just continue that guy on there, put a little arrow tips. And yes, there you go. Connect the dots just like that. And this makes the most sense to me because it's a cubic function. We would expect 3 zeros. We have one of them appearing right in there somewhere, and we've got 2 of them as it bounces off the axis. That's a double root there at 1, 0. So that would be all 3 of ours, right? Unless it did something like that. You could squeeze in 2 more, but we know 1 lands on 0. So the fact that it's landing there means you can't have another one doing this on either side of it, because then that would require like another turn up inside of it, and then it's no longer cubic, right? Okay, any questions there? No? Then you have the rest of the period and more of the day if you need it to finish 2 through 6. And we'll save the next page for tomorrow. So with that, I leave the rest to you.